All right. We talked about an example, very simple example of how we can learn multiplication table using machine learning. We started off with an multiplication table like 1 into what gives 2, 2 into what gives 4. Okay. If you are able to, this is the input, so we call it as data. Okay. And this is the output or the labels. Okay. Where we are feeding in the information. Okay, given 1, we need 2, given 2, we need 4. So this way of giving data and the labels for the machine to learn is called supervised learning. If you want the machine to learn without the labels, that is called unsupervised learning. This example is a supervised learning example, and and this is the function as we discussed is going to learn the pattern y is equal to x into 2. Okay, and anything which forms kind of if you graph this equation y is equal to f of x, it is probably going to y is equal to 2x. It's going to probably have a straight line, and any and like but if you given the value 1, it is going to be 2. It is going to if x is 2, it is 4, it is 3, it is 6. So it forms a linear equation. Okay, hence it is called a linear equation. So not every problem is linear. So this example is an example of a supervised linear regression. Okay, so that is what this example is all about. And similarly, if you want to do classifications, like if you wanted to classify two objects, like let's say you take an image of an apple, and you can take an image of a sweet lime. This is actually not an orange, it's a sweet lime. If you want to classify these two, okay, and there you will not get labels like 2 or 4. You will get probably classes. Okay, class, let's say we call class 0 for apple and class 1 for sweet lime. We kind of run an algorithm to find similar function f of x. In that case, it will not be linear regression. It will be a kind of a logistic regression. Okay, so kind of classify these two examples. Okay, so that's in a nutshell how learning happens for classification and regression. Now let's get into some of the mathematics of how the components behind how things can be learned. Okay, so we talk about input. Okay, that is the data. Okay, we have a single dimension input here. So we capture all the input. Let's say in what we call it as an input vector, and we have multiplication of guesses initially, and then we kind of narrow down to the right guess, okay, by systematically moving towards right. So initially we started with 1, then we had an error, okay, like error was when it was 1, error was like 1, then we incremented 1 to 1.5, the error became 0.5, okay, because the difference between the actuals and the output is what's an error. Then we guessed 1.75, the error became 0.25, and then we guessed 2, okay, then the error became 0. So we multiply with certain numbers starting with random guess and slowly incrementally. So this is what we call it as we capture all the in the different guesses and try to incrementally go towards this. This is captured in what we call it as a matrix. Okay, and we call it as weights actually for the machine to learn. So the input is captured as vectors and the weights are captured as matrices. Okay, and we manipulate the weights. We do some multiplication, so it is like matrix vector multiplication. Okay, and then we get an output either in the form of linear regression, like in terms of numbers, or classes like 0 or 1. Okay, so now okay, now we had an option to kind of narrow down the error, right, from 1 to 0.5 to 0.25. So we need a mechanism to find, okay, if I change the initial guess from 1 to 1.5, are we increasing the error or decreasing the error? So if you want to deal with changes, okay, understand a small incremental change to the guess and the impact of its output, we need calculus actually. So to figure out the small amount of change and the impact of the change on the actual output. So that process we need calculus. So we have talked about vectors, matrices. This is linear algebra. We talked about calculus to kind of derive the loss, okay, and try to manipulate it. And in addition to this, we would also talk about I mean like trigonometry, where if you wanted to kind of find the impact of any rotations which happens because of the matrix vector multiplication. Then we will talk about the geometry of how things we talked about the linear equation, right? This is an example of geometry. So how the equation the linear equation is formed, okay, and then representation of it is geometry. Then we'll talk about and we talked about the two different classes, right? Apple or sweet lime, and when we talk about classes, we talk about probabilities, okay, and try to estimate which is highly probable. And then we will talk about when we deal with large numbers, okay, and we deal with, and we want the computers to work with large numbers, and it makes sense to kind of make it as an addition, okay, and make it the computations easy. If you wanted to convert multiplications into kind of additions, we use logarithms, okay, to kind of transform it, okay. Then in order to really fully understand the impact of probability and the learning, okay, we will also need to know about the information theory. So there are quite a lot of concepts behind mathematical concepts behind this learning, starting from linear algebra, that is dealing with matrices and vectors, then calculus, dealing with the changes to the input weights and its impact on its output, okay, and then representation of it through visual means for like geometry, and understanding the probabilities. We need probability theory, okay, information theory. So we'll talk about all in detail to kind of get understanding of how things work.